Hello and welcome to this video on congruent shapes, which is one of the many shape topics on the GCSE Maths Foundation syllabus. So the main skills we're going to be looking at today is you should be able to identify pairs of congruent shapes and then explain why different pairs of triangles can be congruent. So first of all, let's have a look at the sort of keyword itself. What does congruent actually mean? Well, if two shapes are congruent, they're both identical in terms of the shape and the size. So they're exactly identical to each other. And one key thing to remember is shapes can be congruent even if one of them has been rotated or reflected. So if we take a look at this little picture here, we can see with these two triangles, this has been rotated 90 degrees. So it's gone 90 degrees clockwise. So even though it's been rotated, it is still identical to each other. And these two, obviously, these are facing in the same direction, these trapeziums, so these ones are congruent. And if we look at these here, we've obviously got two triangles here. These are not classified as congruent because they're obviously different sizes. And down the bottom, we've got a trapezium and a parallelogram there, so they're different shapes. So it's impossible for them to be congruent. Right, let's have a look at some examples then. So one typical sort of question they might ask you in an exam is they might just ask you to identify some pairs of congruent shapes. So I'd like you to pause your video and see if you can figure out which shapes out of these are congruent. Okay, let's have a little look at this then. So one pair we've got is A and C. So if you take a look, we've got a rectangle that on this sort of square grid is 3 squares. It's also 3 squares there. It's just been rotated. So A and C, if you were to sort of get a bit of tracing paper and trace over this, you would be able to fit it over the A and it would look exactly the same as each other. Okay, now the other set, it's a bit trickier with the other ones. So we've got D and H there as well. This is just kind of a reflection of H there, but if you were to flip it back, it would fit. If you trace this and flip your tracing paper over, you would be able to fit it on top of that sheet. Remember, you are allowed tracing paper in exams, so that can sometimes help with topics like congruent shapes. Okay, so that's the first skill that we're looking at, which is identifying pairs of congruent shapes. And I think I've seen come up more often on AQA exams. Anyway, I don't know about Edexcel, but on the AQA that I teach, is being able to explain why different sets of triangles are congruent. So you might be told that they're congruent, and then you'll be asked why they're congruent. So we're going to go through 4 rules which relate to this now. Okay, so there are 4 special rules for congruence. And if you've got 2 triangles, they must pass one of these rules to be classified as congruent. If one of these rules does not apply, they will not be congruent. So the first one is this: side, side, side. We'll go through what all these mean in a second. Second one is angle, side, side, angle, side, angle, which is ASA. Then we've got SAS, which is side, angle, side. Then we've got RHS, which is right angle, hypotenuse side. So your first one is this. So we've got SSS, side, side, side. So if 2 triangles have all 3 sides in common, so if all 3 sides are the same length, so on this one we've got 5, 8 and 9 on both of them. So because of that, it will definitely be congruent. Okay, it's just obviously this is kind of a reflection of, almost a reflection really, of the other triangle. So there's your first rule. So if all sides are the same length, they would definitely be congruent. Next rule then is angle, side, angle. So if we've got 2 angles that are the same side, same size, then we definitely know these are going to be congruent to each other. And if we've got a length that's the same as well, so you can see on this one we've got a 30 degrees, a 65 degrees, and then we've got the 5 centimeter length there. So we definitely know that these 2 sides, these 2 triangles, are congruent to each other. And your next one is SAS, so side, angle, side. So if we've got two sides that are the same and then we've got an angle that's the same, then we definitely have enough evidence here to show that these triangles are congruent to each other. So if you did do a bit of tracing on one of these and moved it around a little bit, you would find that the outline would fit at some point. Final one then is right angle hypotenuse side. So if we've got a triangle with a right angle and we've got a hypotenuse and another side that's the same length, that is again enough evidence to prove that these triangles are congruent to each other. So you can see here you've got a 5 centimeter and an 8 centimeter length, and then you've got your right angle. And the 8 centimeter here is the hypotenuse on both of these triangles. So that's the longest side on both of these triangles. Okay, so it's got to be the hypotenuse for this rule to work. Okay, so let's have a look at a couple of examples then. So question 1, these two triangles are definitely congruent. So all we want to know is, why are these two triangles congruent? Okay, and here is your reason then. So SAS is the reason you're looking for. You can just write that in an exam in some cases, but it's side, angle, and side. So we've got the 18 centimeters and the 6 centimeters, and then we've got this angle of 65 degrees there. So that proves that these two triangles are congruent to each other. Let's do one more then. So why are these two triangles congruent? So pause your video and have a go. And here we are. So we've got this rule for this one is right angle, hypotenuse, and side. You've got your right angle down here. We know the hypotenuse and we know the side. So that proves that these two are congruent to each other. Okay, and that's it for your video on this topic then. So I will be doing lots more videos, so please hit subscribe and you'll get loads more content over the next few months. I will be doing a video on similar shapes, which does tie in a little bit with this topic. Okay, thanks very much. Bye bye.